Question 9. Now, first principles. The formulae book does actually tell us this just here. And the idea is, if you've got a curve, the idea behind differentiation, so you're trying to work out the gradient, and to work out the gradient, you look at 2 points. And the best way of trying to find out the gradient at a particular point is that you kind of just move just a tiny bit away from it. And then you're trying to work out gradient of the tangent just there. Right, so that's the idea. Now, we're looking at this just here. So let's just feed this in to what we've got just here. So what's that going to give us? So we're going to have cos of theta plus h. So that's like that little distance there that we've got. Now obviously we kind of effectively, h should be approaching 0. So we've got that, and we're going to take away cos theta. I'm just following this over here, and divide by h. Right, so working from there. Now we should also know our addition formulae. So if we just look at our addition formulae, so cos theta plus h. Now you'll see this is cos A plus B, and that's equal to cos theta cos h, and then have sine theta sine h, and a takeaway. Now that is in the formulae book, but it just says A and B. Okay, so let's just feed this, take this bit, and we're just going to rewrite, and we're just going to put it there. So let's see what we end up with. We've got cos theta h, take away sine theta sine h, take away cos theta. And remember, it's all over h. Right, okay, now again, let's see. Oh, I know. Let's have a look at this bit and this bit. If we write those together, we can factorize. We've got a common factor of cos theta. So let's write this down. So we've got cos theta, and that's going to be multiplied by cos h minus 1. Okay, so that's that part and that part. And then we've got sine theta sine h. Right, now let's start thinking about breaking this up. Look at what it told me here in the question. Just here, as h is approaching 0. And this is just working on our small angle approximation. So we'd normally kind of write those down, but it tells us, so it makes everything much easier. So let's just break this up. Effectively, we could write this as 2 fractions down here, and it's just going to make our life so much easier. So cos theta, and then kind of that bit, and then we got sine theta, and that bit. Right, what did it tell me above? Okay, so let's take this bit. So that's going to approach 0. So effectively, that bit is 0. And then the other bit, that sine, it's telling me effectively that approaches 1. Right, don't need to worry. If you want to, the idea behind it, look, if you use small angle approximations, that's going to be h. So therefore, those two things will just cancel out, be like a 1. Okay, right. And then, so this part here, that's going to be 0. So you can have cos theta multiplied by 0. And then you've got sine theta multiplied by 1. So therefore, it's all equal to sine theta. So we can say that if we were to differentiate cos theta, it must equal, oh, nearly forgot the sign, didn't I? The minus there. Okay, so I'm going to get minus sine theta, and that's true because h is approaching 0. There you go.